All right, this is day 2 of 3.6. So yesterday we graphed rational functions that had end behavior asymptotes that were either 0 or horizontal. Today we're going to focus on slanted asymptotes, and so that's going to really be our focus. So slanted asymptotes, we kind of briefly talked about it yesterday, but we didn't do specific examples. But if your degree in the numerator is larger than that of the denominator, then you're going to have a slanted asymptote. So it won't be horizontal, it'll actually have a slant to it. That's why it's called slanted. And you get it because if your degree on top is larger, you should be able to divide them. So you can do synthetic. Remember, if your leading coefficient is 1 and it's linear, or if you're not dividing by a linear expression, then you do long division. Regardless of what division process you choose, you're going to disregard the remainder, which is kind of nice. So you just kind of start the division and ignore the remainder. So if you look at the graph below here, you can kind of see the slanted asymptote. The ends of the branches there are approaching, and you can see it has a slant to it. It's not horizontal. It has a slope. It looks like it's crossing at 5, and it looks like the slope is maybe 1. And so the equation of that line would be like y equals x plus 5. But you're going to get that equation through the division process. So let's look at an example. So you did these yesterday, and finding like vertical asymptotes, x-intercepts, y-intercepts, all of those ideas remain the same. So you note that when you're finding the vertical asymptotes, you solve that denominator. So x plus 2, set it equal to 0, and you will get x equals negative 2. So that's going to be your vertical asymptote. So you could kind of go over to the graph and place that. And then your x-intercepts, you solve the numerator. While if I factor that first, it would be easier to solve. And then you can see your intercepts are going to be at 4 and negative 1. So again, you could place those points, negative 1 and 4. And the y-intercept, of course, if you plug 0 in for all of the x's, 0, 0, you'll be left with negative 4 over 2. So your y-intercept will be 0, negative 2. And again, you could kind of graph that point. And so the end behavior is really the only thing that's going to be different today. So again, because the degree on top is larger, squared, than that of the denominator, linear, I can do division, and I can do synthetic because I'm dividing by linear, x plus 2, with a leading coefficient of 1. So taking the coefficients from your numerator, 1, negative 3, negative 4, dividing by negative 2 since I'm dividing by x plus 2, and you know the synthetic process, so you can kind of check over that work. And if you remember, I said we don't care about the remainder. So that remainder of 6, I don't care about. So because this was quadratic, remember when you do synthetic, you go down 1 degree. So this is 1x minus 5, and that would be your asymptote. So you're going to have a slanted asymptote that has a y-intercept at negative 5 and then a slope of 1. So just to give you an idea, I think you probably know how to graph lines, right? So y-intercept at 5, slope of 1. So really with these 3 points, you can already kind of tell there's a slanted hyperbola branch right there. But we'll look into that a little more closely. So clearly, I mean, whenever you have a vertical asymptote, it splits the graph. So you have to have another piece, and I don't have any other points. So I would pick up my calculator, and you can see in my y1, I have the equation typed in there. And when I graph it in a standard window, I only see this top branch that we could already kind of tell from the graph. So please make sure you understand, again, if you have a vertical asymptote, you should have 2 pieces of graph. So I know it's probably hiding over here, so I'm going to change my y minimum in my window to, maybe negative 25. Just make sure it's kind of, big enough that I can see that other branch. And sure enough, there it is. Your calculator won't show you any asymptotes, but you can see them. You can see the vertical asymptote at negative 2. You can see that slanted asymptote at x minus 5. And then I would just go, if I were graphing this accurately for a test or something, go to your table and plot some points. So, negative 3 and negative 14 is good. You get the idea. So I'm just going to plot a couple points like that. And then, of course, you can draw those hyperbola branches in there that we saw from your calculator. So yes, absolutely, kind of using your calculator to help you. So the one thing I don't have on here that we should talk about for sure, your domain, remember x can be everything except -2. So it's not that vertical asymptote, never ever can touch the verticals. And then your range, you would probably have to approximate or go back to your calculator at that point and to get a feel for like what this minimum and maximum point are kind of from your calculator. But your range is everything greater than this point, and I know that that's -2. So -2 to infinity. And then also my range is, whatever this point is. So I would just maybe approximate like -12. So negative infinity through -12. So just kind of talking about that visually and making sure you can cite the domain and range as well. All right, let's look at another one. So again, your numerator is larger than your denominator. Okay, so to get my verticals, I would, factor out the 2 probably first. So that's really 2 and then x squared minus 4. And then you know that x squared minus 4 factors down to x plus 2 and x minus 2. So my vertical asymptotes are going to be x equals 2 and -2. And behavior. Okay, so I can't do synthetic because I'm dividing by a quadratic. So now you have no choice but to do long division. So I'm going to take x cubed divided by 2x squared minus 8. Okay, so when you divide 2x squared into x cubed, remember you're really thinking about like x cubed and then you're dividing by 2x squared. That's your thought process, right? And I know it's not that hard, but I will see people mix that up often. Oh, I don't want a green dashed line there. I just wanted a fraction bar. So you can see here that this reduces to x on top over 2. That's where the 1/2 x came from. So 1/2 x, and then you multiply 1/2 x times 2x squared is x cubed. 1/2 x times -8 is -4x. Subtract all the way through. So really you're just carrying down the positive 4x. And then I can't divide because x squared doesn't go into x. So I know then that y equals 1/2 x is my slanted asymptote. So when you come over to the graph, I know that it's going to cross at 0, y-intercept, and then the slope is going to be over 1, up 2, over 1, up 2. You can kind of see that slanted asymptote in there at this point. I could put that in again with the green dashed line. And then you could put your verticals in there as well. So I know I'm going to have verticals at 2 and -2. So you could get those in there. Whoops. Well, anyway, now I'm just going to get rid of those because that's getting in the way. So here is the graph from the calculator, which is fine because we were getting there anyway. So you can see that the vertical asymptote is at 2. The other vertical asymptote is at -2. And then you can see that slanted asymptote starting at 0 and then going up 1 over 2. And I can actually kind of dash that in, that slanted asymptote. So up 1 over 2, down 1 over 2. So you can see I dash in a little asymptote there. Now remember, your pieces of graph can cross through the end behavior asymptotes. Clearly this piece is crossing through. You can't cross through verticals. So you're going to have your 2 verticals. You can see that one there and that one there. Your graph will definitely not touch or cross through that. But the end behavior asymptote, your ends have to approach it. So these 2 ends are definitely approaching that slanted asymptote. Before I didn't mean to unveil the graph, but if you solve your numerator, x cubed equals 0, well, just 0 is going to be my x-intercept. And if my x-intercept is 0, 0, then my y-intercept is also, well, you can see that graphically. So again, if you pull up your calculator, and I will, even though you see what it looks like here, but I will turn on the second graph as well. on my calculator so you can kind of see that graph. And you already could see the picture, but just reminding you if you needed more points, because really with this one, all you got was 0, 0, and that was not very helpful. So you are likely going to want to go to your table from your calculator, pick out a couple other points, even if you have to approximate, like 4 and then 2 and 2/3, etc. Because obviously you can see on your calculator what it looks like, but we'll be looking for some exact points as well. So making sure you draw a nice, neat, accurate graph. The domain on this one is everything except -2 and +2. Remember, it's always everything except those vertical asymptotes. And then my range, because this middle piece goes on forever up and down with no holes or breaks, my range is all real numbers. So -infinity to infinity. All right,